everyone, welcome to class. Obviously our recording did not work out for me yesterday. That was a disaster. Hopefully you guys didn't have as many troubles as I did. So thank you for bearing with me. I know there's been a few times of this, so I do appreciate it. We are looking at a new week for mystery numbers, so we're looking at week 12, day 1. So make sure when you submit those mystery numbers, you're submitting them to the proper drop box. This week, I did send out a K-mail with some adjustments and some changes. So I ultimately took out the assignments for Monday and Tuesday here. So yes, there was issues yesterday. I also knew that I wanted us to really focus in on reviewing for this test. And then on Thursday and Friday, we'll go through our new unit here. So we'll kind of push everything back, and it's just a week. So hang in there. Next week, we should be back to pretty normal stuff. All right, so through this unit, we talked about solving equations, looking at equations and graphs, and then we applied it to those area problems. Now, I know some of you said that you struggled with those area problems, so we will try to solidify that. And do, like I said, that was one that I would go through and make sure you're paying attention to that video there. Okay, so let's start with graphs. We talked about a parabola, and a parabola was just a U-shaped graph. In order to form a parabola somewhere in your equation, you had to have, that's not a very good color, an x squared. You had to have a variable that was going to have an exponent that was squared on it in order to create a parabola. From that parabola, we can look and we can actually see that our goal was to find these x-intercepts, to ultimately graph this. If we could find this x-intercept on this line of symmetry, we had enough information to graph a parabola. So we found these x-intercepts by factoring, which we spent a lot of time factoring on a unit, last unit and the unit before that. So looking for where does it cross that x-axis. Ultimately, y was going to equal 0, and x was going to have a specific value. Now that value was going to change depending on the parabola, but finding it through factoring the quadratic formula or completing this square was our goal. So we could look at this and we can have multiple types of parabolas. We could have where there is 0 x-intercepts. That means it's never going to cross the x-axis. And an example of that would be this graph here. However, it also could be upside down, never crossing, like this graph here. Both of those have 0 x-intercepts because neither of them cross that x-axis. Then we also could have where it crosses one time. And that means the exact center of our parabola, where our line of symmetry is, was going to only have one x-intercept. And that ends up happening when we factor, when we find our quadratic formula, or when we compute the square. And we get the same answer 2 times. So maybe we'd get x equals 2 and x equals 2. Well, then they're the same number, so that tells me the point is going to be in the exact same location. And our third option, and this is kind of our most common option, is actually that we have 2 x-intercepts. And you can see that here and here. Now, the graph can be pointing upwards or it can be pointing downwards. It doesn't matter when we're talking about our intercepts. And that would be when x equals 2 different points. So maybe x equals 4 and then x equals -6. Well, you can see that there's 2 different numbers. That tells me there's going to be 2 coordinates where parabola crosses the x-axis. So there's some different characteristics of parabolas that you have to remember. Our points can either point up, meaning it points like a U, or it points down and it's an upside down U. This is determined by whether x squared is positive, then it's going to point up, or whether x squared is negative and then it'll point down. So really, you don't have to do any math on this one. You just have to determine if x squared is positive, it's going to be pointing up, like in the typical fashion here. Or if it's negative, then it points down. So negative is down, positive is up. We also can look at our roots or solutions and our x-intercepts, and that's what we just talked about. Does it cross one time? So is there one time where it crosses, which would be the vertex, does it cross 2 times? And the roots, the solutions, and the x-intercepts, they're all the same thing, just a different name. So then we'd have 2 specific intercepts, and that means our graph is going to cross 2 times. Or does it cross 0 times, and it's never going to touch the x-axis? So it never touches x-axis. Then we also can determine whether a graph is going to be below or above the axis. So these two can kind of be connected. Well, if it has one vertex, that means it's touching the x-axis. So it's not going to be above and it's not going to be below. It's going to be on it. It really comes down to, is it going to cross 2 times or is it going to cross 0 times? And if it crosses 0 times, is it above or is it below? And again, you can use that by determining how many roots there are. So once you find those roots, then you can say, okay, if there's 2 roots, it's going to be crossing it 2 times, so it's not going to be above or below. If it's crossing 1 time, it's touching it, so it's not going to be above it or below it. So then it's really, okay, if it's crossing 0 times, what does my graph look like? So it ultimately has to do with, what does my graph look like? We can use the formula negative b over 2a to tell us about that. Okay, so we could solve quadratic equations in ultimately 4 different ways. We could factor, and remember, solving this is going to tell us what those roots are, what those solutions, what that x-intercept is going to be. So we could factor, and we talked about different factoring last unit. So greatest common factor, perfect square trinomials, difference of squares, and then just regular old factoring. We could solve an equation. So x squared plus 2 equals 11, where you subtract 2 and you get x squared, and then you take the square root. That would be solving an equation. Yes, we will go through examples in these in just a minute. We also talked about completing the square, where something was missing. If we had x squared equals 2x and it equaled 12, we didn't have information here. So we had to find that last piece. Or we just straight up used a quadratic formula and said, I have no idea if any of these other 3 are going to work. This will always work. It takes a lot more effort, a lot more time, but it'll always be consistent. So if we're looking at these options here, my title disappeared on us. If we're looking at these options, you can see then they have multiple answers here. So this one was just straight factoring, where I have x squared plus 2x plus 1. And I could separate those into x plus 1 and x plus 1. Well, hey, that's the exact same number. And I said if it had the same number, that there was only going to be 1 point that crosses their x-axis. That would be our exact vertex. Over here, then, they still factored. But what they did is they found that there was 2 solutions. And remember, when there's 2 solutions, we always have to use the opposite because we have to set both equations equal to 0. So even though it looks like it should cross at -3 and +2, it actually crosses at the exact opposite, and it crosses at -2 and +3. So remember, you want to do the opposite there. So now this would tell us that there are 2 places this crosses the x-axis. Over here, they just did this straight quadratic formula, where we had negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, they didn't show you step by step, but I said the first thing you should do is always label which point number represents a, which point represents b, which point represents c. That way, when you're substituting it in, it's easy and clear and concise for you. Then they just went through step by step. This was our b. You can see it's taken here. Then we have our c is a -3, and that's right there. Then we had our a, and there's no number in front. If there's no number in front, then we assume it to be a 1. And you can see that that shows up then here and here. And then they just solved and started doing the math. They found that they ultimately got 2 solutions. That means our graph is going to cross at 2 distinct points. Again, helping us figure out these different characteristics of the parabola. All right, then we looked at completing the square. Now completing the square, typically when we've seen the problem, it actually starts at this step, where there's the number that's on the right-hand side, and it looks as if there's something missing here. Now you can see on the very bottom step, it's clear that it's missing here because we have a very empty box. In order to find what goes there, we need to look at our b. So we take half of our b, so half of -8 is -4, and then we square -4. -4 squared is going to give me 16, and that's the number that completes my square. That's what's going to be filled in on both pieces. So what I get is -24 plus 16, I get -8. Now this is a perfect square trinomial, and I can factor it that way. And I just need to solve my equation step by step. So let's look at some examples here. Okay, so I have two separate things going on here. The first one I have is just a regular old equation where there's no greatest common factor. X squared is not by itself, so I can't complete the square. So I'm just going to solve this. And in order to solve it, I just start solving it like an equation. So I have my left and my right side, and I'm going to add 7 to both sides. This will cancel out, and so I'm left with 25x squared on the left and 16 on the right. Well, then I can divide by 25 because my goal is to get that x squared by itself. So I have x squared equals 16 over 25. At this point, I just want to take the square root of both sides. When I take the square root of a fraction, I can separate it. So I take the square root of 16 over the square root of 25, and I would get a positive 4/5, and I'd also get a negative 4/5. I need to take both pieces into account, the positive and the negative solution. So that would tell me that at positive 4/5 and at negative 4/5, my parabola is going to cross 2 times, so they're going to be two x-intercepts there. So 2 roots, 2 solutions, 2 x-intercepts. If we're looking at the problem on the right, I can't factor this. I can't solve this equation because I have an x squared and an x. That doesn't help me. But this would be a great problem where I could complete the square. So I'm going to rewrite this. And I'm going to leave a blank here so that I can figure out what number goes in the middle. So I look at this 14 and I take half of 14 and I get 7. Then I do 7 squared and I get 49. That tells me that 49 is going to be the number that completes my square. So I put 49 here. In order to keep things even, I add 49 to both sides. Pen does not want to cooperate with me. Okay, so I get x squared plus 14x plus 49 on the left, and then I get 15 plus 49 on the right. Sometimes it's easier not to do the math in my head. Don't laugh. My pen does not want to work. That is not good news. There it goes. Okay, so then on the left, what multiplies to 49 adds to 14? Well, I get x plus 7 squared. X plus 7 times x plus 7. Well, x plus 7. 7 plus 7 gives me 14. 7 times 7 gives me 49. So then I can take the square root of both sides because x plus 7 squared and 64 are perfect squares. So I get x plus 7 equals positive 8, and x plus 7 equals a negative 8. In order to do that, I subtract both sides. So I subtract and I get a positive 1. I subtract and I get a negative 15. All right, so make sure you complete your test, submit some mystery numbers. Your mystery numbers today will be 12 and 42. Have a fantastic day, and thanks for